Let's look at examples of finding or determining x and y intercepts of various functions. And before we do that, let me remind you what intercepts are. So let's move this over here. Recall an x-intercept is a point, okay? It's an ordered pair. Is a point where a graph touches the x-axis. Doesn't have to pass through, it just has to touch the x-axis. And, you know, of course, we could say the same thing about a y-intercept, basically. A y-intercept is also a point where a graph touches the y-axis, okay? So we'll find some examples of these here, and we'll start with just a basic graph. So let's determine the intercepts in this example. Oops. Okay, so here we have the graph of some function, and I want to find the intercepts. Well, let's start with the x-intercepts. The x-intercepts are where the graph touches the x-axis, which is right here and here, and they're ordered pairs. So this ordered pair is 2, 0, and the other is 4, 0. Some people would just say it has x-intercepts of 2 and 4, which is, I think, acceptable, because if you're telling someone they're x-intercepts, then you know that they're on the x-axis. So 2 and 4 on the x-axis would be fine. But to be completely precise, ordered pairs are better. Let's look at the y-intercepts. Y-intercepts are where the graph touches the y-axis, and here it touches the y-axis at one point, which is the ordered pair 0, -2. And those are the intercepts. Now, let me make a comment here about intercepts, though. Not every function has intercepts, okay? So I'll make a note of that here. Note, not every function has intercepts, because not every graph touches the axes, the x or the y axes. So you might have y-intercepts with no x-intercept, you might have x-intercepts with no y-intercept, or you might not have any intercepts at all. So here's an example of a graph that does not have any intercepts. It's a pretty common function that you may or may not know, but if you don't, that's fine. So this is kind of what a square root function can look like sometimes. And you can see it goes to the right forever and up forever, but it stops over here. So this graph has no intercepts at all. So algebraically, it's interesting to see why that's true. Okay? So now I want to remind you, if we go back and look at our previous example, notice that the x-intercepts have y coordinates of 0. That's not a coincidence. Every x-intercept has a y coordinate of 0, because any point on the x-axis has a y value of 0. And similarly, y-intercepts have an x value of 0. That's because any point on the y-axis has an x coordinate of 0. So I've written that here. X-intercepts have a y of 0, y-intercepts have an x of 0, and now we'll find some intercepts without the equation of the function, or sorry, without the graph of the function, but with the equation of the function. So let's see, f of x equals x minus 2. So if we want to find the x-intercepts, we have to set y equal to 0, meaning we're going to solve for x, so we better know a value for y. Now in this equation, where's y? Well, y is the same thing as f of x. So we'll replace f of x with 0, that entire value with 0. So 0 equals x minus 2. Notice that x is the unknown here. Notice the variable is x. If you want to find an x-intercept, you never plug a value in for x. You're trying to figure out x if you want to know the x-intercept. And you add 2 to both sides, and you can see that x equals 2. So the x-intercept is the ordered pair where x is 2 and y is 0. So x is 2 and y is 0. So the ordered pair 2, 0 is the x-intercept. It has one x-intercept. The y-intercept, you do the same thing, except you're going to solve for y, which means you need to plug 0 in for x. So this equation is y equals x minus 2, but we're plugging 0 in for x, so we get 0 minus 2, and we can see that y equals negative 2, which means that we get the ordered pair where y is negative 2 and where x is 0. So 0, negative 2 is the y-intercept. There's only one. Okay, so that's a very basic example to get you warmed up here. Let's try some harder ones. So here we have a quadratic function, and let's say we want to find the x-intercepts. We're going to plug 0 in for y, which is f of x, so we get 0 equals, and we're going to solve for x, so we're not going to plug anything in for x. And now we have a quadratic equation, so we're going to solve it by factoring, and we can see that x plus 1 has to be 0, or x minus 4 has to be 0, which means that x has to be negative 1, or x has to be 4. So we get two x-intercepts, which remember y is 0. So this x-intercept is the ordered pair negative 1, 0, because y is 0 for that x value. And for this x-intercept, x is 4 and y is also 0. So we get two x-intercepts for this particular function. It crosses the x-axis or touches the x-axis twice. The y-intercept will plug 0 in for x and solve for y. So this function is f of x, which is y, equals x squared, so 0 squared, minus 3 times 0 minus 4, which 0 squared is 0, 3 times 0 is 0, minus 4 gives us negative 4. So we'll get the ordered pair where x is 0 and y is negative 4. And that's our y-intercept. Okay, let's try another. F of x equals the absolute value of x plus 3. So for the x-intercepts, we have to plug 0 in for y. So we get 0 equals the absolute value of x plus 3. Let's get the absolute value by itself here. So let's subtract 3 from both sides. And so now we're trying to figure out which x values make this true. In other words, what can you plug in for x so that when you take the absolute value of it, you get negative 3? Well, that's impossible because the absolute value of a number can't be negative. Impossible. Absolute value of any number is not negative. So what does that mean? This equation is impossible. That means there is no x-intercept. You can't find any x values that make it true. So this graph doesn't touch the x-axis. As far as y-intercepts go, set x equal to 0, and we get y equals the absolute value of 0 plus 3. Well, the absolute value of 0 is 0, so we get 0 plus 3, and we get y equals 3. So that gives us the ordered pair. X is 0, y is 3, and we get one y-intercept. Okay, so that's an interesting example. We don't get any x-intercepts in that case. Let's do another one. Here's a function that has a fraction in it, and we're going to find, it's called a rational function. We're going to find the x-intercepts. We're going to plug 0 in for y. So we get 0 equals x minus 2 over x plus 3 plus 4. And probably the easiest thing to do here would be to subtract 4 from both sides. And then, when you have an equation with fractions, you try to get rid of the denominator. So we'll multiply both sides of this equation by x plus 3. So I'll multiply x plus 3 times negative 4. On the right side, the x plus 3's cancel. That cancels the denominator like we wanted. So we have x minus 2. And on the right side, we have to distribute our negative 4 to get negative 4x minus 12. Now we just finished getting x by itself. So let's subtract x from both sides to get negative 5x. Let's add 12 to both sides to get 10. And divide both sides by negative 5 to get x equals negative 2. So that gives us an x-intercept of x being negative 2 and y being 0. All right, let's do the y-intercept. We're going to plug 0 in for x. And so we have y equals, because remember, f of x is y. So we have y equals 0 minus 2 over 0 plus 3 plus 4. So y equals negative 2 over positive 3 plus 4. And when we add those together, we get negative 2/3. 4 as a fraction is 12/3. So negative 2/3 plus 12/3 is 10/3. So that's the ordered pair where x is 0 and y is 10/3. So there's our y-intercept. So there are many examples of finding the x-intercepts and the y-intercepts. The thing about this is your function, your original function here, could be defined in so many different ways. It could be quadratic, it could have an absolute value, it could have a fraction, it could have square root. Regardless of what type of function you have, you're going to plug 0 in for one variable and solve for the other. Now, depending on your background, you may not know how to solve the equation. Maybe you didn't know how to solve the equation with fractions. So that's where the difficulty comes in with finding intercepts is, can you solve the equation or not? Okay, so I want to show you a few examples here and remind you of a few basic concepts on solving equations, but also I wanted to emphasize how to find intercepts.